Good evening, students. We will see some more problems in goodness of it. Here the question is, a sample analysis of examination results of 500 students are made. It was found that 220 students have failed, 170 have secured a third class, 90 have secured a second class, and the rest are first class. Do these figures support the general belief that the above categories are in the ratio 4 is to 3 is to 2 is to 1 respectively? So here we are taking 500 students. Out of 500 students, 220 students have failed and 170 secured a third class, 90 have secured a second class, and the rest are first class. It is given clearly in the question. We have to examine whether the above categories are in the ratio 4 is to 3 is to 2 is to 1 respectively. So here totally 500 students are here and 220 are failed and 170 have secured a third class, 90 have secured a second class, and remaining 20 have secured the first class. This is the data given, and we have to examine whether these data are made in the ratio 4 is to 3 is to 2 is to 1 respectively. So here these are the observed frequencies. So we can conclude it is a chi-square test for goodness of it because we are taking a 500 students. Out of 500 students, we have categorized according to the frequency, that is 225, 170 third class, 90 second class, and 20 first class. So the frequencies are given. So we are concluding it is a chi-square test for goodness of it. First, we have to set H naught. So how will you set H naught here? The results in the four categories. In the four categories or in the ratio or in the ratio 4 is to 3 is to 2 is to 1. This is our H naught. Next, we have to set H1, which is nothing but the results are not in the ratio 4 is to 3 is to 2 is to 1. This is our H naught and H1. In step 2, we have to calculate the expected frequency. We know the observed frequency. What are the observed frequencies given? It is 220, 170, 90, and then 20. These are the observed frequencies given. How to find out the expected frequency? In the last class, I told you, I have given one example, that is digits were given and frequency were given. And in that case, we have find out the expected frequency is mean of the digits. But here it is not the case. Out of 500, the observed frequency is 220. 220 students were failed. But here the ratio was given 4 is to 3 is to 2 is to 1. So if you add all this 4, that is 4, 3, 2, 1, you will get 10. Out of 10 members, 4 have failed. But here we have taken 500 students. So how will you calculate the expected frequency? It is 4 by 10 into 500, which is nothing but 200, right? And what is the next one? It is 3 by 10 into 500, which is 150. 2 by 10 into 500, which is 100. 1 by 10 into 500, which is 50. So we got the expected frequency. So if ratio was given, you have to add all the ratios up. Here, if you add all the ratio, you are getting 10. Out of 10 parts, 4 parts are failing, right? So 4 by 10, that is out of 10. But we are calculating for 500 students. So 4 by 10 into 500. And how many students are getting third class? It is 3 by 10 into 500. And then second class, it is 2 by 10 into 500. And first class, it is 1 by 10 into 500. Next, you know very well, it is OI minus EI, the whole square, divided by EI. So you will have, it is 220 minus 200. OI minus EI, which is 20, the whole square, 20 the square, divided by the expected frequency, which is 200. So you will get 2 here, right? And the next one, 170 minus 150, the whole square. So that you will get 20 square again, divided by 150, which is 2.667. And the next one is 90 minus 100, which is minus 10. Minus 10 the square, which becomes 100. 100 divided by 100, which is 1. And then 20 minus 50, which is minus 30. Minus 30 the whole square divided by 50. So I'm getting 18 here. So if you add these values, you will get 23.667. 23.667. So my chi-square value was, because we know very well the chi-square formula was I varies from 1 to n, OI minus EI, the whole square divided by EI. We have added these values. So this is equivalent to 23.667. This is our chi-square value. Next, in step 3, you have to calculate the table value. Already I told you the degree of freedom for chi-square goodness of fetters n minus 1. Here we are having 4 values. 4 minus 1, which is 3. The degree of the table value at 3 degrees of freedom for 5 percentage level of significance. So you have to see under the table, which is 7.815. In step 4, you have to compare this value as well as this value. Here the calculated value was greater than table value. Therefore, we have to reject H now.